Okay, we want to find the equation of a line tangent to the cylinder r equals 10 at the point 10 power 3 8. So hopefully you do something, and you can definitely choose where you want your axes. So I noticed Morris put his x-axis here and his y-axis here, z-axis going up. You could do that, or you can draw your, x here, y here. It doesn't really matter. The whole point is to get a kind of a visual on this thing. So I think I'll go with Morris's here. So here's your cylinder. It has a radius 10. So I guess the negatives would be over here and here. And here's your cylinder, like that. And it stands straight up, like this. Okay. And then you're trying to imagine a line, and it's located at one particular point on here. So 10 pi over 3 8 is clearly a cylindrical measurement. Okay? This must be r, this must be theta, this must be z. How do I know that? Because of the way it's written, the middle is obviously an angle. The others are probably not angles, right? So if you're never quite sure, you say, Mr. Are these x, y, z, or is this like r, theta, z? What are you giving us here? I'd be happy to answer that, okay? But I think it's pretty obvious it's cylindrical coordinates. So radius 10, naturally, it's somewhere on the red cylinder. Pi over 3, that's a very specific angle. And 8, that's a very specific y or z coordinate. So basically, if you go out a radius 10, which means you're going to be on your cylinder, and you do that at 60 degrees, and then you go straight up 8, you'll find yourself at that point. So I should probably erase some of these invisible portions of my cylinder. This would be more like, dashed in the back. Okay, so here we are up on the cylinder. This is right on the surface, on the lateral surface of the cylinder. It's right there. And we're trying to create a line. The equation of a line. The equation of a line is, as we saw Friday, vector r of t equals x naught, y naught, z naught plus t abc. That was our lesson on Friday. If you weren't here, you should probably watch that video. It's kind of hard to learn this stuff without some instruction. Okay. But the green dot is your x naught, y naught, z naught. Okay? So you do need to convert your green point from 10 pi over 3 8 into x, y, z. Okay, so I'll give you a second to do that. We're trying to write it actually as a vector, x, y, z. So go ahead now and convert that point, and then the position vector for that, we'll put brackets on it. Okay? Okay, Morris is right. We're going to use r cosine theta to get our x, and r sine theta to get our y. Okay? So what is 10 cos pi over 3? Because that's supposed to be your x. Yeah. Well, actually, are you in degrees mode or radians? Put your calculator in degrees and type 60, or put your calculator in radians and type pi over 3. But don't mix radian mode with typing degrees or vice versa. What did you get? 5, yeah. It's basically 10 times a half, right? So this is just simply 5. And then we need our y. So 10 sine pi over 3. So that's just 5 add 3, right? Okay. As for the z, we just get to steal the 8. The 8. Okay, it's a little hard to see. Sorry, I'll write it a little bigger. So we're saying that our answer is, this is the same exact point as 5 root 3 8 in rectangular coordinates. And so that's where the green dot is in my little cylinder picture. Okay, so that's actually what I'm going to use as a position vector. So 5 root 3 8 plus TABC. What does A, B, and C mean? It's kind of your slope. In a very real sense, it's like delta x, delta y, delta z. Okay? But we haven't drawn our line yet. Here's our line, by the way. Tangent to the cylinder. So it's supposed to look like it's kind of brushing up against the cylinder and just barely touching it, like a bullet, grazing off the edge of a barrel or something. Okay? Now, if you think about it, there are actually many, many lines like this one. This is not a unique line at all. Okay? Let's say that this is my line, okay, and my cylinder is this piece of paper right here, this packet of paper. If you roll this into a cylinder and you want to stick a line up against it, watch my hand, there are lots of orientations for this line, right? Just because it's touching the line doesn't really tell us much. But one thing is true, when you look at all of these from up above, watch my head, okay, looking down on this, it doesn't matter what tilt angle I give it, the trace of this line in the XY plane is the same. In other words, from bird's eye view, if you're looking from above and looking down, you see the same image every time. Okay? So it doesn't matter what tilt that was. So I think we should draw like a bird's eye view. So from the top, top view, quote unquote, you're looking down on this thing. We're going to put the X here and the Y here now. The cylinder is right here. You're looking down upon the lid. And right here at 60 degrees, there's this line. See? And it might be tilted such that it passes through the XY plane, or it might not. So I'll show you again with my hand. So here's your cylinder. It's sitting upright on your desk, right? Here's the line, the green line that you're interested in. It's touching a certain point. We don't know if this stick, if you watch my hand here again, this is a very visual thing, so if you could look. Okay. We don't know if this stick actually hits the desk or over here or not. It might be totally horizontal to the plane, right? Or parallel to the plane. We don't know anything about that. But from top view, they all look exactly the same. I can't tell the difference at all. Okay? So what I'm saying is the delta z on this problem is anything you want. The rising of the line in the z direction is anything you want it to be. I'm going to say 0. The instruction said find the equation of a line tangent. I'm going to make delta z 0. C. If that makes sense. It means I'm holding my stick completely flat above the desk. That's what it means. Okay. Now we just need delta x and delta y, which you can do many different ways. I need the slope of this line. Notice it's perpendicular to the radius. Right? You give me the slope of this green line in 2 dimensions. Just give me m. Okay? You do it a number of different ways. Give me m for this line, and I'll steal the rise and the run from your fraction and stick them in right here for my a and b. I'll put my run, comma rise right here. So try it now. Not too hard, not very far from the answer at all. Get the slope of that line, steal the numerator as your b, and your denominator as your a, see? And you got it right, run and rise. Delta x, delta y, a and b. Get the slope of the green line. If you want to do implicit differentiation, this is the circle x squared plus y squared equals 100. Find dy dx. When theta is 60. Or just do something to find the slope of that line. Or you guys can look at it this way. There's a little right triangle here. This is 5, and this is 5 root 3. So you should be able to find the slope of the black segment. Once you have the slope of the black segment, the green one is perpendicular to it. Right? A tangent line is always perpendicular to the radius that connects to that tangent line. So the black and the green are definitely perpendicular here. That's an old radius tangent theorem from geometry days. All I need is slope of that green line, and we're done. also recording it, so if you want to see the ending of it, you can. And I'll send solutions to our worksheet tonight. Make sure you guys turn them in today. They go in the basket. Okay, so what's the slope of the black segment anyway? What's rise over run? No, the hypotenuse is 10. I want to know the slope. So I'm trying to find the slope of this green line. The slope of this green line will help me understand how the x's change and how the y's change. It's basically delta y over delta x. So what's the slope of the black? 5 or 3 over 5, right? So root 3. So the radius has slope root 3 over 1. So what about the green guy? What's his slope? Negative 1 over root 3, right? So listen, this is your delta y, you could say, and this is your delta x, you see. And those are a and b. Those are a and b. So just stick them into here. So this would be root 3 and this is negative 1. How do I know who gets the negative? Is it, do I give the negative to the delta y? Or do I give the negative to the delta x? Like, maybe I should do like negative root 3 comma positive 1. How do I know? It doesn't matter because if t is negative 1, and it's supposed to take on all real values, so if t is ever negative 1, these will reverse anyway. So now let me just explain. This is our final answer right here. We just got it. Let me just explain one more time what we accomplished and why this works. Okay? So let's say that, I guess I don't need to record this part. Can't really see it anyway. Let me stop recording. 5